Welcome back, everybody. This is going to be your video for lesson 9.1, which covers angle relationships. Due to time in this unit and the amount of time that it would take to do this explore activity, we're not going to do it. We are just going to skip over that and start working on the actual section. But one really big important thing here is that it gives you the vocabulary word congruent angles. Remember, you have to remember congruent is equal. So anytime you have congruent angles, it means they have the same measure. So that is a big key part of the angle stuff that we're going to be working on in this unit. So let's flip it over to the beginning of the section. It says, vertical angles are opposite angles formed by two intersecting lines. Okay, you should be familiar with these vocabulary words. We did an entire section on it, an entire unit of work on vocabulary words. Vertical angles are congruent because the angles have the same measure. Adjacent angles are pairs of angles that share a vertex and one side but do not overlap. And we'll get more into examples of those. Complementary angles are two angles whose measure have a sum of 90 degrees. Supplementary angles are two angles whose measure have a sum of 180 degrees. And this is talking about the explore activity, but we didn't do it. So what you would have found from the explore activity is that adjacent angles formed by two intersecting lines are supplementary, meaning that they have a sum of 180 degrees. So let's look at our diagram. It says name a pair of vertical angles, so angles that are across from each other that are equal. So they say AFB and DFE. See, these two lines intersect each other, so their opposite or vertical angles are equal. So then it says name a pair of adjacent angles. They used AFB and BFD. Remember, they need to make 180 degrees. They're going to make a straight line. So see, this one comes right here, and then this one goes right here. They're touching, they don't overlap, and when you add up their measures, they would be 180 degrees. So then it says, name a pair of supplementary angles. Well, you could just use the same one because your adjacent angles also form supplementary angles as well. Alright, find the measure of angle AFB. Use the fact that AFB and BFD in the diagram are supplementary angles and find the measure of angle AFB. So this is what we're looking for, AFB. So we know if we add AFB and BFD, they have to equal 180 degrees because they're supplementary and they're adjacent. So what we could do is X, which is what AFB is, and then we know that this means 90 degrees, and we know that this is 50 degrees, so 90 plus 50 is going to give us 140. So X plus 140 equals 180. So remember back to our equation solving, we would subtract 140 from both sides. We do our inverse operation, and then we end up with X equals 40. So the measure of angle AFB is going to be 40 degrees. So pause your video, and then when you come back, your answers to the reflect questions will be here. It just says, what is the relationship between angle AFB and angle BFC? And explain. And then are angle AFC and angle BFC adjacent angles, why or why not? Okay, for number 3, AFB and BFC are actually complementary angles. So they are complementary angles. And explain, we could just put that the sum of their measures is 90 degrees. The sum of their measures is 90 degrees. So are AFC and angle BFC adjacent angles, why or why not? So let's look. We got AFC and BFC. No, these cannot be adjacent angles because even though they share a vertex, they overlap. So no, they do share a vertex, but they overlap. So you're looking for something along those lines. It doesn't have to be word for word exactly like I said, but something along those lines for sure. Alright, so next page, we've got a your turn. So once again, pause your video, work out the your turns, and then when you come back, I will have my answers there. So for supplementary, I'm going to go with angle FGA and angle AGC. AGC. For a pair of vertical angles, that's the ones that are across from each other, I'm going to go with angle FGE and angle BCG. Angle BCG. And then find the measure of CGD. So CGD. That's the one that we are looking for. So, let's see here. This is going to be 55 degrees. Okay, if you need some help, remember you've always got your personal math trainer. You could request a workshop. There is a math on the spot video. You can always log back into the textbook if you need a little bit of extra guidance, or you could just ask for help, which is always a good plan. Alright, so angle pairs and two-step equations. So that's our next section. It says, sometimes solving an equation is only the first step in using an angle relationship to solve a problem. Find the measure of angle EFH. So EHF. EHF. So first of all, we need to look at, okay, how do EHF and FHG, how do they relate? Well, they make a straight line, so they're going to equal 180 degrees, which means they're supplementary. So we know if we add these two together, they have to equal 180 degrees. So you would do 2x plus 48 equals 180. So using our rules for solving, we have our inverse operation is subtraction, so we're going to subtract 48 from both sides. And 2x equals 132 degrees. So then if we divide both sides by 2, because what we do to one side we do to the other, we would get x equals 66 degrees. So since angle EHF is 2x, then it has to equal 132 degrees. Sometimes they ask you to find the angle measure, so you have to plug it back in. Sometimes they just ask you to find the value of x. You need to be prepared to do either one. So for another one here, we've got one that are complementary. So we have angle WXZ and angle ZXY. Now they're complementary, so that means they have to have a sum of 90 degrees. So when we add these together, they have to equal 90 degrees. So we have 35 degrees plus 4x plus 7 equals 90 degrees. So we can combine the 35 and the 7 to get 42. So we have 4x plus 42 equals 90. I'm going to subtract 42 from both sides and then divide both sides by 4, and x is going to equal 12. So this time they want you to find the measure of x, y, z. Okay, we know x equals 12, so we need to plug it back in. So 4x minus 7, we're going to substitute in 12 for x. 4 times 12 plus 7. So we use our order of operations. 4 times 12 is 48. 48 plus 7 is 55. So this angle right here is going to be 55 degrees. Alright, so what you will need to do for the your turn is you will need to pause the video and find the angle measure of JML, and then you will need to answer question 9. When you come back, check your answers. They will be here for you. Alright, so for this one, I would do 54 plus 3x equals, they're supplementary, so it would be equals 180. So I'm going to subtract 54 from both sides. These cancel. This becomes 3x equals, let me see, 180 minus 54. That's 621 equals 126. So then I'm going to divide both sides by 3. 126 divided by 3. That's going to be 42. So my x value equals 42. So since JML is 3 times x, I have to do 42 times 3, which is going to end up being 126. Okay, so says Corey says that to find measure of angle JML above, you can stop when you get to the solution step 3x equals 126. Explain why this works. You can stop right here because where you find the value, that's where you find the value of 3x already. Because the angle measure of JML is 3x. But like I said, you have to be able to solve it out all the way as well, because your question could ask you to find the measure of JML, or it could ask you to find the value of x. So you have to be prepared to do either way. Okay? So just kind of giving you a heads up on that. Alright, next. So, using angle measures in triangles. Says you learned earlier that the sum of measures of angles in any triangle is 180 degrees. That is something that you should come in here knowing. You can use this property in many real-world situations. It says, the front of the top story of a house is shaped like an isosceles triangle. The measure of the angle at the top of the triangle is 70 degrees. Find the measure of each of the base angles. Make a sketch, okay? I always tell you guys, always draw the picture. And we know it is an isosceles triangle, so we know that these two sides are the same. And if these two sides are the same, their angles have to be the same as well. Okay? So, we know if we add x plus 70, since all the angles of a triangle add up to 180, we can make our formula. So, let's combine our x's. We have x plus x is 2x. So, then we get 2x plus 70 equals 180. So, based on my equation solving, I know I'm going to subtract 70 from both sides. So, then I get 2x equals 110 degrees. And then I will divide both sides by 2 so that I can isolate my variable, means getting my x by itself. And so then x equals 55 degrees. So that each of the base angles in this situation equals 55 degrees. So pause your video and do the your turn problems. You're going to use this diagram here. You're going to find the value of x and find the measures of angle A and angle B. Go. Alright, so for the value of x, I got 25 degrees. So I knew that I could do x plus 3x plus 80, and that was going to make me equal 180. So I combined my x's. I got 4x plus 80 equals 180. So then subtract 80 from both sides, and that gives you 4x equals 100. Well, this was one that I already knew. I didn't have to divide. What goes into 100 4 times? 25 does. So my x is going to equal 25. And then, so angle A is going to be 25. So then 3 times x, well, if x is 25, 3 times 25 is 75. So 25, 75, and 80 will add up to be 180 degrees. So it is going to be up to you to complete the guided practice for this section. I will have an answer key over in the answer document area for you to come check when you're done. So good luck, and if you need any help, be sure to request a workshop on the workshop wall, or ask your neighbor, or ask me for help. That's what I'm here for. Thanks, guys.